Okay, today we're going to talk about 1.1 day 2, which is a couple of equations. The first one is using the segment addition postulate. The second one's going to be distance formula, and then the third one's going to be the midpoint formula. From 1.1 day 1, we had an IXL code that does go with the assignment. This one also goes with the assignment. So this one, after watching this video, you should be able to do this IXL assignment. All right. So the first thing we're going to talk about is the segment addition postulate. And in our classroom, we did this in a nauseating attempt because I wanted to be solidified in my students' brains that a piece plus another piece equals the whole thing, equals the whole segment. And we're actually transferred to angles after this too. But the first piece plus the second piece equals the whole thing. Okay? So when we look at this, and it says let points A, B, and C be collinear, so they're all in a line. And if B is in between points A and C, so B is going to be in between A and C, then it begs to the question of the first piece plus the second piece equals the whole thing. And if you think about it in a chocolate bar sense, if I have a first piece of chocolate bar and I chop it to give my friend some, and I have the second piece, putting those two together gives me the whole chocolate bar back as a whole. So we're going to use this idea of a piece plus a piece equals the whole thing. So when we do this, what we want is, what is the first piece? So we're going to look at this picture and go, the first piece is going to be from K to L. So from K to L is our first piece. Then we are going to add our second piece. And our second piece is going to be this one right here. And we start at L and we go to M. So this is going to be L to M. And then at the very end, we're going to equal the whole thing. Now, what a lot of students love to do is go K, L, M. And I know why, because we want to go all from start to finish all the way through, and we don't want to miss anything. But let me ask you this. If I'm going to school, if I start at home and I'm going to go to school, do I talk about every single red light I hit along the way trying to make it to school? Do I talk about all the twists and turns? No, it's just from home to school. So when we talk about this, we just want to talk about from beginning to end, the two endpoints of our line segment. So we talked about line segments in the last section. It's just an endpoint is a start and then a finish. So where are we starting, where are we finishing? Okay? So now geometry becomes substitute and solve, and substitute and solve, and substitute and solve. You will do this at length for geometry. So the first piece, K to L, is 9. So I'm going to substitute 9 in for K to L. Then I'm going to put in LM. LM is right here. From L to M is 5. And then the last one, let me turn to a purple. The last one is going to be from K to M. And K to M, we actually don't know. But in math, we have a game that we play when we don't know something. We use a variable, an unknown, or a letter to represent that we have no idea what it is. So we're going to put X there. Okay, so then if I do that, I've substituted 9 in for K to L. L to M is 5, and then K to M is what I'm looking for, my variable. So 9 plus 5, well, that's 14, equals X, and X originally was Km. So what is Km equal? Equals 14. So now I've found my solution. And that's essentially what we want to do for this one as well. Is we're going to do the first piece plus the second piece equals the whole thing. Okay? Once we do that, what is the whole thing? Oh, that's 12, so I'm going to put 12 in for it. underline it. And then the second piece is a question mark. And the first piece is an 8. So then let's put in our 8 plus question mark. We know to use a variable, so we're going to use x. Now we have a one-step equation we need to solve for. And why is it an equation? Because we have an unknown and we have an equal sign. So in order to solve for the highlight, so we're going to solve for this x, we have to get rid of everything that's on the same side of that highlight. So everything over here, well, I guess it's over there. I got to do the opposite. So on that side, we are going to get rid of this 8. So the opposite of a positive 8, so 8 minus 8 will be 0. We're going to subtract 8. And what we do to one side, we want to balance out and do it to the other side. So this 8 take away 8 is 0, but we still have an x here, so we're going to keep that x. And then 12 minus 8 gives us 4. So we know our solution for this piece from B to C is going to be 4. And if we do it, we double check. 8 plus 4 does give us 12. All right. So let's move it and make it just a little bit trickier. Not a lot, but a little bit. So now we have points A, B, and C. They're collinear. So once again, we have 3 points that are on a line. It does not have to be in the middle. It could be a little bit more over here. This is not drawn to scale. Okay, so be careful with that. And it says point B is in between A and C. So I want to put B between A and C. And a lot of times this is how you're going to want to construct your line segment when it tells you this stuff. And you're going to see this more than once. Okay, they like to do this in math. Even on the SAT, you're going to see this. So A to C. So from beginning to end, they told us it's 3x plus 3. So beginning to end, this is going to be 3x plus 3. Then it says, so we did that one, AB is 2x minus 1. So from A to B is 2x minus 1. And lastly, B to C, so B to C is just going to be 11. Okay? So when we write our piece plus a piece equals the whole thing, we're going to start with the first piece is A to B plus B to C equals A to C. The first piece plus the first piece plus the second piece equals the whole thing. Okay? And if I were to do this, I would say the first piece right there plus the second piece right there. I have to do everything backwards. Equals the whole thing. So do that. And then use your highlighter and really use colors. Colors can help a lot. So A to B. What's A to B? Then what is B to C? What's B to C? And then A to C. What is A to C? Use those colors to help your brain stay organized in what we're doing. So A to B is the yellow, so that's going to be 2x minus 1 plus B to C is 11 equals A to C, 3x plus 3. So that's how I establish my colors and try and organize my brain to see those things. Now take out your highlighter again. I use a completely different color every time, and I'm underlining my variables, and then I draw a line down the middle of the equal sign. What that's going to establish is they're all going to be on one side or the other side, or they're going to be on opposite sides of my equal sign. And that's going to tell us something. If they're on the same side, one side or the other, all we need to do is combine like terms. We can do whatever the operations are and get them together and hug them together. And one of those you see in this problem is this 11 minus 1. These are on the same side of the highlight. Everything's on this side. I don't want to do that to throw people off, but everything's on this side. So when I do 11 take away 1, or negative 1 plus 11, that's going to turn into a 10. Because all I'm doing is combining two terms that are on the same side of the equal sign and putting them together. So if I do that, now I'm setting this up. I still have my highlights that are on opposite sides of the equal sign. So what I'm going to do is move one of them to the other side. And how I take a positive 2x and get rid of it is I'm going to subtract 2x. Because 2 minus 2 is 0. So I'm going to subtract 2x, and I'm going to be left with 10 on that side. But what I do to one side, to balance it out, I have to do it to the other side. So 3x minus 2x is just a 1x, and then drop down your plus 3. So that starts to simplify my equation a little bit more. Now I just have x over here by itself, but I still have a plus 3 on the same side. So I need to move that plus 3 to the other side in order to get what x actually equals. And then I'm going to do 10 take away 3 without my face being in the way. I apologize for that. So I'm going to take away 3 from both sides so that x can equal 10 minus 3, which is 7. Now, the question says find x, found x, and AB. And I didn't find AB. So now I better tell what AB actually equals. And AB, we could go back up here, tells me that. Or AB right here tells me that. It's 2x minus 1. Uh-oh, got an x. But I know what x is. So let's plug it in. So AB equals 2 times 7 minus 1, which is 14. Take away 1. So AB is going to equal 13. And that's going to take care of that segment addition problem. Okay, this one, pause, try it on your own. I'm gonna try a time lapse where I just present the problem. So we'll see how this works. I'm gonna try this. Here's our situation where the x's are on the same side. So hopefully you got to here for the setup. But now look at these highlights. The x's are on the same side of the equal sign. So put them together. 1x plus 1x is 2x. 10 plus 14, 24. And set it equal to 22. Now there's only one highlight. So that tells me I need to get rid of the 24 and the 2 because those are numbers that are on the same side of the equal sign. So let's start with the plus or minus number. So because it's plus 24, I'm going to start with that one and subtract it so that I get 0. Now, still have the 2x. So I'm going to leave that. And then, oops, I put a plus and it should have been. Let's go back here. Sorry. Should be minus 24. So that when I do that, 22 minus 24, I should get a negative 2. I still, however, have this 2, so I'm going to divide both sides by 2. And then x is going to equal negative 1. Find x, found x. And BC, got to do BC. And between B and C is x plus 14. Negative 1 plus 14, and by coincidence, BC is going to be 13. And I say by coincidence because I think that was the answer for, last one. That's just coincidental. Doesn't mean that every answer is going to be 13 by any stretch of the means. Okay? So, there we go. So we got BC, we got X, and we're done with that problem. On to the next. In the next one, we are going to start the distance formula. Now, the distance formula is a little bit different. We are looking for what is the distance between A and B. We want to know this length. And it would be great if it was just from here to here. We could easily count 1 jump, 2 jump, 3 jump, 4 units. It's 4 units long. But because we're going on a diagonal, we're not jumping at nice, clean units. So there's a formula, and I'm only going to do this formula once, and then we're going to look at the hack for the formula. So we're going to find our ordered pairs. So to find the points, A. So we'll start at 0, 0, and we're going to go back left 1, 2, 3, 4. So that's going to be negative 4. And then we're going to go up, which is a positive direction, 1, 2, 3, 4. And we're just going to fill out these ordered pairs. So B, we're going to go right 1, so that's a positive 1. And we're going to go up 2. That's a positive direction. Right and up are positive directions. Left and down are negative directions. Okay? All right. Let's move on to the next one. Okay. And we'll go to C. So C, we're going to jump 2 to the right. And then we're going to go 1, 2, 3 up. Both positive directions. D. Let's go 1, 2, 3, 4 to the right. So that's still positive, but we're going to go down 2 units. So that's going to be a negative 2. Okay. And for the rest of them, I'm going to do in black. So give them a shot. See what you can come up with for these answers. But E, we're going to go left 1, 2, 3. So that's going to be a negative 3. Up 2. Positive. F, negative 2, negative 3. G, negative 2, negative 4. H, 2, 0. Okay, so now we've got our ordered pairs. We are going to find the distance between A and B. So A was negative 4, 4. B was 1, 2. Negative 4, 4. 1, 2. 1, 2. Negative 4, negative 4. What we want to do is the distance between the 2 points, x1, y1. So I am going to label this x1, y1. Well, why is it 1? Because it's the first point you wrote down. That's all. And then this is the second point you wrote down. So we're going to label it x2, y2. Okay? There's no more thought process that goes into it than that. Then our formula. D equals the distance equals the square root of parentheses x2 minus x1, square it, plus y2 minus y1, square it, and then take the square root of the whole thing. That's how you would answer that. What I like to do is after I write the formula, copy everything down that we see, except for the x2s, the x1s, the y2s, and the y1s. We're going to plug in values into these. So whatever this is, x2 is going to go here. Whatever is x1 is going to go there. Whatever is y2 is going to go here. And whatever is y1 is going to go there. Oops. Yes. Should stay consistent with what I'm doing. There we go. All right. So the first one, x2, we're going to come up here and highlight x2. So x2 is just a positive 1. x1 we did in green. x1 I see right here is going to be negative 4. y2 is in blue. So find y2 and the blue one, and we're going to use 2. And then y1 we did in pink. We're going to find y1, highlight that, and we're going to use the number 4. So if we rewrite all of this cleanly without all the highlights and parentheses and all of that, we're going to get 1 minus minus, a negative negative makes a positive. 1 plus 4, we're going to square that. And then we're going to do 2 take away 4, and we're going to square that. One of the things you have to be consistent with, especially in the distance formula, is get an answer and keep it in parentheses when you square it. Because when you get a negative answer, this has to turn to a positive solution. Otherwise, you're going to be in trouble. And you're going to get answers that don't make sense, or you're going to get errors on the calculator. So we do 5 squared, we're going to get 25. We do negative 2 squared. I promise you that is going to give you a positive 4 if you put it in parentheses. And while I'm thinking about it, let's do this. So if I do, negative 2 and square it, see how I get negative 4 here? But if I do parentheses negative 2, and then I square that, I get a positive 4. So I get 2 different solutions. One that's in parentheses, one that is not. Please keep your answer in parentheses. It will save you. It will save you, I promise. So then we get d to equal the square root of 29. You'll play with these enough. SQRT will give you that square root 29, and you can do 5.4. You can say this is 5.4 and be done with that. So that the length from A to B is 5.4 units long. You can simplify the radical. We do that in other classes. We're not going to spend a whole lot of time rationalizing this. But you would look for your perfect squares. If you can pull any of those out, you can't. 29 is a prime number. So this is as simplistic as the answer is going to get mathematically. And you can adjust it so that it's just a decimal number to 5.4. However, this is how we're really going to look at the distance formula and how you really want to focus on the distance formula. If I'm going to go from C to D, this will make your life super easy. I need the distance from C to D. What I'm going to do is break it up into a Y direction piece and an X direction piece. Because if I can do that, I can just use A squared plus B squared equals C squared. Now what you need to understand, the only letter that matters in Pythagorean theorem is your C value. Your C value is really the only one that's important. But the reason the C value is important is because we have this thing called the right angle. Okay, it's a 90-degree angle. And we're always going to go directly across from that right angle, and that has to be our C value every single solitary time. So if you see this right angle, go across from it, that has to be our C value. We might know the length of that C value, we might not. That's what you need to use every single time. So if we do that, break up our A, we're going to jump 1, 2, 3, 4, 5. So this A equals 5 jumps. And you could think about jumping it up 2, 3, 4, 5, or down. So we don't have to worry about positive or negative values. We're just talking about jumps. B, we are going to jump 1, 2. 2 jumps. And we could jump left or right. And remember, when we put them in here, we should be putting them in parentheses, so no matter what, our answers are going to come out positive. So you could call it negative if we go to the left, or down. You can call them negative. But that's all going to get caught up or dried out in the wash because we're going to put parentheses around it, and it doesn't matter positive or negative. Our answer is always going to come out to be positive. So when we do this, write your formula. A squared plus B squared equals C squared. And we know C is pink, so we're going to keep C pink. we did A in green, so I'm going to keep A in green, and B was in blue, so we're going to keep B in blue. So our green value, I guess I should be a little bit smarter and say our B is blue and A is green, so that when we say, okay, that A we said it was 5 jumps, well, that's the number we're going to put in here, 5 and then square. And then our B value was in blue, we said is 2 jumps, and we're going to square that. And then C is what we are looking for. So I'm going to keep C as C and keep the squared sign. So now, 5 squared is 25. 2 squared is 4. 5 times 5, 25. 2 times 2, 4. This just tells us the number of parentheses we have. So this will have 2 parentheses, and each parenthesis is going to have the same thing. So 5 times 5, that's how we get 25. Which is the same thing for, like, if I had 5 cubed. It tells me how many parentheses I have, and I'm going to fill in each one of those with whatever's inside. So 5 times 5 times 5, that would give us 5 cubed. Just quick exponent lesson, a little history lesson, if you may. So then we get C squared to equal 29 again. So we're back to this 29 idea. However, we have 29 equals C squared. We don't want squared, we want just C by itself. So we need some kind of rule that's going to help us out to get rid of a squared sign. And that rule being from the distance formula is called the square root. So we're going to take the square root of both sides. Now, was the square root already on our paper, or did we put it on our paper? If we put it on our paper, we have to put a plus minus in front of it. Even though we don't talk about distance being negative, and we won't, we'll ignore it. But good math practice, if my brain says to do the square root, put the plus minus in front. It will pay dividends forever if you get into that habit. So please put the plus minus in front, and then square root both sides. So now we are going to essentially get rid of the plus minus because we only want to focus on the positive, because distance can't have a negative. Distance just tells you direction. And then the squared and square root sign, the reason we did it in the first place is so that these would cancel out, and then we'd be left with C. So C is the square root of 29, which we said already was 5.4. Okay? Now, what I'm hoping is that you will take some time and do EF and GH, get some practice with that. But I have to go to midpoint. So, using these same values that we found, we're going to talk about the midpoint formula. So what is different from this slide to the other slides is our equation. And the midpoint, and you can look over here, is we are really looking for the middle of our line segment. And you might call it X sub M and Y sub M. That's what I like to use to refer to the midpoint, because they have you X1 and X2. I'm going to use XM for the midpoint and YM for the midpoint for my point M. All right, so with that being said, we want to find where the middle is in this line. So what we need are our 2 ordered pairs. So A, once again, being -4, +4. And B being 1, 2. I'm actually going to keep them both pink. So 1, 2. These are our 2 points that we want to find the midpoint from. So label it X1, Y1 because it's the first point I wrote down. X2, Y2 because it's the second point I wrote down. Don't overcomplicate it. And then let's write our formula. Our formula is going to be X1 plus X2 divided by 2. Then we're going to do Y1 plus Y2 divided by 2. And now comes color coordination. So once again, let's color coordinate everything. So X1, 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 keep that formula alive. And then we'll do x2, x2, x2. So you really have to pull from both sides for just the first thing. And remember, we're looking for the middle right here. Somewhere, I don't even know. I don't know where it is, but it's somewhere here. In between A and B. We're going to have M. But remember, M is still just a point. It's still just an x comma y. So I am looking for an ordered pair, an answer that has just a number comma number. So we want to break up this idea of into the x's and then to the y's. Okay? y2, y2, y2. Now let's piece our puzzle together. And let's put some parentheses, plus parentheses, comma, parentheses, plus parentheses. And let's color coordinate it again. So yellow's going to go on the first, then green, then blue, then pink. And start to see where these things are coming from. So x1 comes from my first number in my first ordered pair. x2 comes from my first number in the second ordered pair. So you have to borrow one value from each of the points. Get into that routine. So many people make the mistake of just taking -4 plus 4. Just taking this point, adding it together, dividing by 2. That's not what we're doing here. We're taking the x value and the x value, and now we're going to take the y value, y1, and the y value 2, and put those together. Combine like terms, or we can rewrite it as -4 plus 1 divided by 2, and then 4 plus 2 divided by 2. We're just cleaning it up so it looks nice and neat. And I'm going to get -3 over 2, and I'm going to get 6 over 2. One of these is going to be a nice clean 3, but the other one's going to be a -1.5. So we're going to go back 1.5, and you can see right in between -1 and -2 is roughly where I put that guess. And it does fall on 1, 2, 3's line. Okay? And this is our midpoint of the line segment AB. Give this one a chance, E to F. I'm going to try and time lapse this out again so that I can do it fairly quickly. 1, 2. And there we go. Hopefully this is what you got for the midpoint, which would fall -1, 2.5, and then down just a half. So they're saying right there is where our midpoint for E to F is going to be. And if you look at this, yeah, that looks roughly in the middle. Okay? So I know this is a lot. We had segment addition postulate. We had distance formula. And we had midpoint. We really did break this up into a multiple day kind of thing. It gave time to get this practice in, okay? So don't feel if you didn't get it the first watch through, watch it again. And watch it again, or go to one of the specific sections, whether it's the segment addition, the distance formula, or the midpoint formula. We are going to have plenty of practice in this in class, and please continue to ask questions. This is not an easy topic, and there's a lot of topics in this one topic. Like we're talking segment addition, we're talking distance formula. In the distance formula, we even talked about the Pythagorean theorem and how that affects it. And then we went to midpoint. So there's a lot of moving parts in this section, and I don't want one of those parts to fall off. So please do your best and get as many questions as you can answered, okay? All right.